Okay, so this question, first let's write down what z plus 1 is. We know x plus iy is z, so z plus 1 will be x plus 1 plus iy. I've just written 1 next to x because it's a real part. It doesn't matter even if you wrote it there. And z minus 1 is x minus 1 plus iy. Now the modulus of z plus 1 over z minus 1 is the same as modulus of z plus 1 over z minus 1. So what is modulus of z plus 1? So it's the real part, which is x plus 1 squared, plus the imaginary part, y squared, square root. And the modulus of z minus 1 is similarly x minus 1 whole squared plus y squared. Now we are told the modulus of z plus 1 over z minus 1 is greater than 1. So these two things can be written over one another. And they are greater than or equal to 1. So squaring both sides, you end up with this. And then if I move the denominator to the right-hand side, I have x plus 1 whole squared plus y squared is greater than or equal to x minus 1 whole squared plus y squared. Now I'm going to expand the left-hand side and the right-hand side, which will give me x squared plus 2x plus 1 plus y squared greater than or equal to x squared minus 2x plus 1 plus y squared. Now when I rearrange and make the right-hand side equal to 0, I will have this and this will cancel out, that will cancel out, and that will cancel out. And I'm essentially left with 4x is greater than or equal to 0, and x is greater than or equal to 0, hence proved.